Here's Dr. L talking to you a little bit more about some more chemistry. What we're going to talk about now is chemical bonds, beginning with covalent bonds. So covalent bonds are chemical bonds that form due to the sharing of valence electrons between atoms. There's quite a few different forms of covalent bonds. For example, there are single, double, and triple covalent bonds. In single covalent bonds, you have two atoms that are sharing one pair of electrons. In double covalent bonds, they're sharing two pairs. In triples, they're sharing three. When you're looking at just each bond, each covalent bond can also be called polar or nonpolar. Polar means like having ends that are different, and nonpolar means the two sides are the same. Polar covalent bonds means the electrons that are being shared are pulled more towards one atom and away from the other. And in nonpolar covalent bonds, the electrons are shared equally between the two atoms. So this is how a covalent bond might form. Here are two hydrogen atoms. Hydrogen atoms have one valence electron orbiting here right next to the atomic nucleus. This orbital can hold two electrons. So hydrogen would love to have two because that's a more stable configuration for this atom. So these two hydrogen atoms, when side by side, will tend to form a covalent bond where they're each sharing their available electron. And there's the shared pair of electrons. This is a single covalent bond because each of these atoms is the same. They're going to be pulling on these electrons the same amount. So this will also be a single nonpolar or equally shared pair of electrons, single nonpolar covalent bond, making the molecule H2. So here's chlorine, a chlorine molecule, an oxygen molecule, and a nitrogen molecule. And all of these tend to exist as together. So for example, most of our air that we're breathing is enriched in O2 gas, right? So you will see a single bond holding these two chlorine atoms together into chlorine gas, and there's the single pair of shared valence electrons. It's a covalent bond. Here's a double bond, and it's shown with two dashes when you draw it like this, O, two dashes, O, and there are two pairs of electrons being shared here in the center. And then nitrogen gas, which is also abundant in our atmosphere, we've got a triple bond holding these two nitrogen atoms together, and there are three pairs of electrons being shared here. In all three cases, these are going to be nonpolar bonds because this is like a tug-of-war between identical twins. Each can pull on these shared electrons with the same force or electronegativity. So let's think a little bit more about this polar versus nonpolar covalent bonds. I'm going to start at the bottom with nonpolar covalent bonds because we just looked at an example of that. So here we've got two atoms. We're just using A and B in this figure, like there's nothing like specific to a specific type of atom. But these two atoms are forming a single covalent bond. They're sharing one pair of electrons. Since both atoms is identical, they're pulling on these atoms with the same or matching electronegativities. These electrons, I think I said atoms a minute ago, but I meant electrons, are going to tend to be at an equal distance from this nucleus to this nucleus. That's a nonpolar bond, making this in total a nonpolar covalent molecule. You can get these nonpolar covalent bonds when you have two identical atoms covalently bonded together, or if you have two atoms that have the same or very, very similar electronegativities. So for example, if you had a carbon and a hydrogen, they tend to have very similar electronegativities, or they do have very similar electronegativities. So carbon-hydrogen bonds tend to be nonpolar, just like a carbon-carbon bond or a hydrogen-hydrogen bond would be nonpolar. Up here we see a diagram like illustrating the ideas of polar covalent bonds. So if you've got atom A and atom B, and atom B in this case is much more electronegative, then their shared pair of electrons are going to tend to be distributed closer to the nucleus of atom B and further away from the nucleus of atom A. Electrons have a negative charge, and so if these electrons that are shared are like over towards B's nucleus, you're going to have a little bit of negativity here and a little bit of positivity here. In other words, you're going to have a partial negative charge around B and a partial positive charge around A. And that is shown with these like little Greek symbols and the minus, little Greek symbol and the plus. And these are called polar covalent bonds. It's not a full charge, it's a partial charge. This is going to be incredibly important when we talk about hydrogen bonding. Covalent bonds are really important in forming molecules, and they're also really important therefore in forming macromolecules, including the macromolecules that make up living things. The 4 categories of macromolecules important in living things are proteins, nucleic acids, carbohydrates, and lipids. Each of them has a building block, amino acids, nucleotides, monosaccharides, and fatty acids / glycerol. Each of them also has a type of covalent bond that holds them together. And by type, I mean we give these bonds special extra names because they're just so important in living things. So peptide bonds is the name for the covalent bonds that hold amino acids together when they form proteins. Phosphodiester linkages is the name of the covalent bonds that we use to say how nucleotides are held together to form nucleic acids, which could be DNA or RNA. Glycosidic linkages are the covalent bonds that hold monosaccharides together into carbohydrates. And ester or ether bonds are important in connecting fatty acids and glycerol to form lipids. This is a little bit of a messier category. All right, and then in the next video I will explain hydrogen bonding to you.